Hello friends, I am Jairaj Rathod welcoming you in the solution session of assignment 9.2 which is based on geometric progress. First of all, let's recall commonly used term in GP. Here one sequence is shown A1, A2, A3 up to dot 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 AN. Let's suppose it is in GP. Then small a will be your first term. Then common ratio is denoted by small r, which can be found from taking a ratio of any two consecutive terms. Normally, we take second term upon first term and the last term, which is denoted by L. Normally, this will helpful to find the number of terms in sequence. Now let's see the common formula which will be useful in the problems. Nth term of GP denoted by Tn is equal to AR raised to n minus 1. Quite easy and useful. Second thing is sum of first n terms of GP. Actually, form of this equation is based on our common ratio r. If our r is greater than 1, then we have to take a r raised to n minus 1 upon r minus 1. And this formula can also rewrite as LR minus A upon R minus 1. This formula is in terms of L, and if you see carefully, you will understand here we don't have any n term. Okay. Now the second form, when R is less than 1, then A 1 minus R raised to n upon 1 minus R, and the same thing with the second form, A minus LR upon 1 minus R. Okay. Now the third condition is when our terms, actually number of terms, is tends to infinity and R is less than 1, then we can say our summation of the terms will be A upon 1 minus R. Third form is actually resultant of applying limit n tends to infinity into the second term. Okay. Now the last one, when common ratio is equal to 1, or we can say we have constant sequence, then the summation will be simply NA. Okay. Now the last important and commonly used thing is if A, B, C are in GP, then we can say B is equal to under root of AC, or we can say we have half power. And one more thing, this B is also known as geometric mean. So remember these things and prepare for solving some example. So let's go. Our question is like, if both 7th and 10th term of GP is A, B and C respectively, then we need to get the relation between A, B and C. So first of all, let's get the value of A, B and C in terms of GP. So we can say our A, which is fourth term, will be capital A, which is our first term of GP, and capital R, which is common ratio of the GP, raised to 4 minus 1, or we can say AR raised to 3. Okay. Now similarly, let's get the value of B, which is T7. It will be AR raised to 7 minus 1, or we can say AR raised to 6. C, which is 10th term, will be AR raised to 9. Now, by visual inspection, you can see option C, it seems to be correct. Let's check it. Our left hand side is actually B square, or we can say we will get AR raised to 6 the whole square, or we can say we will get A square R raised to 12, right? Now in right hand side we have A into C. Let's put the value of A into C. Then A into A will give us A square. R raised to 3 into R raised to 9 will give us R raised to 12. So our LHS is equal to RHS. So we can say B square is equal to AC. Tada! Option C is the correct option. In this question, you should note that 4, 7 and 10 are in AP. Then 4th, 7th and 10th term, which are A, B and C respectively, will also in GP. So it will satisfy the condition of GP, which is B square is equal to AC. So remember this result for future aspect. Okay. In this question, we have the complex series. Actually, this series is in GP with first term is equal to I and the common ratio must be second term upon first term, or we can say minus I, and we have to find the summation of 100 terms because we have 1, 2, 3, 4 up to 100 power terms, right? Which suggests that we have 100 terms. Now let's use the formula of Sn. We are going to choose the second formula in which mod r is less than 1. Okay, so let's use the formula as 100 will be A bracket 1 minus r raised to 100 upon 1 minus r. Put the value of A and value of r, which is minus I whole raised to 100 upon 1 minus r, minus I actually, so it will be plus I. Okay, now it's time to get the value of minus I raised to 100. Actually, we don't have to worry about this negative sign because we have even power, so this negative will become 1. And to get the value of I raised to 100, we have to convert this as a I raised to 4 whole raised to 25 because I raised to 4 is actually 1 and 1 raised to anything will give us 1. So our I raised to 100 is 1. Put the value of I raised to 100 and you will get 1 minus 1. Don't worry about the denominator because we have 1 minus 1, which is 0. So tada! Option D is your final answer. Our next question is, if P plus qth term of GP be M. So we can say TPQ is equal to M and P minus qth term is N. So TP minus Q will be N. Then we have to find Pth term. That means T of P, right? Okay. Now let's use the formula of nth term. We can say AR raised to P plus Q minus 1 is equal to M. Let's call it equation number 1. Similarly, AR raised to P minus Q minus 1 is your N. Equation number 2. And we have to find AR raised to P minus 1, right? Okay, so we should eliminate Q from the two equation, and for that we have to multiply 1 with 2. So left hand side will be AR raised to P plus Q minus 1 and AR raised to P minus Q minus 1 is equal to M into N, right? So A into A will give us A square and R raised to P plus Q minus 1 plus P minus Q minus 1 is equal to M. And here you can see Q will cancel out and we will get A square into R raised to 2 times P minus 2 is equal to Mn. Or we can say here we have AR raised to P minus 1 the whole square is equal to Mn, right? So finally we can proudly say our AR raised to P minus 1 is root Mn, which is nothing but our pth term. So tada! Option B is your answer. Let's see the next question. The question is, if x, 2y and 3z are in AP, so we can say 2y is equal to x plus 3z by 2, or we can say 4y is equal to x plus 3z. Let's call it equation number 1. Now the question, where distinct number x, y, z are in GP. So x, y, z are in GP, and we have to find common ratio R. So we should convert x, y, z in terms of common ratio. No problem. X, y, z are in AP. So we can say our x is the first term A, y is the second term, we can say AR, and z is the third term, which is AR square, right? Let's put this data in equation number 1. So here we will get, instead of 4y, we have to put AR is equal to x is now A plus 3z is AR square, right? We can take A common, so here we'll get 4r is equal to 1 plus 3r square, or we can say 3r square minus 4r plus 1 is equal to 0. Now we just have to get the factors, and the factors are 3r minus 1 and r minus 1 is equal to 0, which suggests that our r must be 1 by 3 or 1. Both answers are correct, but in option 1 by 3 is given, so B will be the correct option. Ta-da! Now here we have one of my favorite question. The question is, in a sequence of 21 terms. So let's consider one sequence having 21 terms. Now first 11 terms are in AP, so first 11 terms will be in AP with common difference 2. So the common difference D is 2, and as you can see, our first term is A1, let's call it A, and the last term of AP is A11, right? Or we can say A11 must be A plus 11 minus 1D, or we can say 10D, right? Now let's move on. The last 11 terms are in GP. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Last 11 terms are in GP with common ratio R is equal to 2. Okay. Now as you can see, A11 is the first term of the GP. So here we have to write first term of GP is your A11. Let's assume it is capital A. Okay. Now let's go for the question. If midpoint of AP be the equal to the midpoint of GP, then we have to find midpoint of entire sequence. Oh my god. Now we have to find midpoint of AP. So the midpoint of AP is actually, we already have 11 terms in AP. So midpoint will be 11 plus 1 by 2th term, or we can say 6th term, T6 of AP. So indirectly we have to find A plus 6 minus 1, or we can say 5D. Let's get this over here. So we get the midpoint of AP. Similarly, let's find out midpoint of GP, and GP have also 11 points. So here we will get 11 plus 1 by 2th term, or we can say T6th term of AP. I should mention it by capital T6, right? Is equal to capital A, which is the first term of GP, into R raised to 6 minus 1, or we can say 5. But capital A, which is first term of AP, is nothing but A11, which is nothing but A plus 10D, into R raised to 5 will as it is. Okay, now in question it is given that midpoint of AP is equal to midpoint of GP. So here we can say small t6, which is a plus 5d, is equal to capital T6, which is a plus 10d into r raised to 5. Now let's put the value of d and r. So here we will get a plus 5 into 2, or we can say 10, is equal to a plus 10 in the bracket 2 raised to 5, or we can say 32. So finally, after solving this, we will get a is equal to minus 630 upon 31, right? But don't forget the question. We have to find middle term of entire sequence. Midterm of entire sequence will be, we have 21 terms, so 21 by 2th term will be our midterm, or we can say A11 is your midterm, right? And we know that A11 is a plus 10d. Put the value of a and d, you will get minus 10 by 31 as your final answer. Tada! Option A is your answer. Let's move to the next question. The first and last term of GP are A and L respectively, and R is the common ratio. Then the number of terms, you have to find N in the GP. Okay, no problem. We should find out the value of N, and for that we are going to use the formula of Tn. Actually Tn, which is our last term, will be AR raised to N minus 1, right? We have to make N subjective, which is in the power. So to make N subjective, we should use the log on both sides. So on left side we will get log L, and on right side we will get log A R raised to N minus 1 as it is. Now first of all, we have to split the right hand side. Log A into log B is log A plus log B. So here we are going to get log A plus log B, which is R raised to N minus 1. Now it's time to use the third property. The power will goes in the coefficient. So second term will become N minus 1 into log R. Okay, now we are close to get the value of N. So let's make it subjective. Take log A on the left side, so it will be negative, and then take log R, which is in multiplication, will go on the right side in denominator. So we will get log L minus log A upon log R is equal to N minus 1, or we can say let's take minus 1 on the right hand side, and we will get plus 1. So tada! Option D is your final answer. You can remember this result as a formula for finding the value of N. Okay, let's see the next question. If S is sum of infinite GP, then the first term A, then we have to find common ratio. Actually here we have to take the formula of infinite GP's summation, which is actually S is equal to A upon 1 minus R, and we have to find R. So let's make it subjective. We can easily say 1 minus R is A upon S. So 1 minus A upon S is your R. So finally R is S minus A upon S. Tada! Option B is your final answer. In this question we have to find 0.5737373 in the fraction form. So first of all, let's call it Sn, 0.5737373. Okay, now let's separate these terms. So we can rearrange as 0.5 plus 0.073 plus 0.0073, actually one more 0, plus 0.1234573 plus dot 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 up to infinity, right? Okay, this 0.5 will remain as it is throughout the question, and from the rest of the terms we can take 73 common, right? So the remaining terms will be 0.001 plus 0.12341 and so on. So you can easily notice that in the bracket we have sequence of GP in infinite sequence, right? Which have first term is equal to 0.01 and common ratio is second term upon first term, which will give us 0.01, right? So let's use the formula of Sn. Our 0.5 and 73 remain as it is. So A, which is 0.001 upon 1 minus R, which is 0.1, right? So let's write down this 0.5 as a 5 by 10. So 73 in the bracket we are going to get 0.001 upon 0.99, right? Actually here I just have a printing mistake, it is 0.01, right? So okay, now let's simplify this. Our 5 by 10 will be as it is. We can say it is 73 in the bracket 1 upon 990, right? Or we can say our Sn is nothing but 5 by 10 plus 73 upon 990. So here 990 will be your LCM, and here we will get 495 plus 73, which will give us 598 upon 990. Sorry, 568 upon 990, right? So option C is your final answer. Ta-da! Here we have one interesting question. You have to find 1.7 plus 2.77 plus 3.77 plus 4.777 and so on. So let's call it Sn because it is the summation of n terms. So our Sn is actually 1.7, 2.77, 3.77 and 4.77. Now here you can see we have 1, 2, 3, 4, which is n natural numbers, and we have 0.7, 0.77, 0.77, right? So let's split the terms. Our first term will split into the 1 plus 0.7. Then the second term can be split into 2 plus 0.77. Then time for third term will be 3 plus 0.777 and so on. So as you can see, in first bracket we have summation of n natural number, which we already know that n into n plus 1 by 2, right? Okay, in second bracket we should modify for converting into some standard sequence. First of all, we can take 7 common from the all terms, right? So let's take 7 common. So we will get 0.1 plus 0.11 plus 0.111 up to so on n times. Okay, now for modification, let's multiply and divide by 9. In next step, this first term will be as it is, and as we plan, let's multiply and divide by 9. So here we divide by 9 and multiply by 9 in the bracket will give us 0.9 plus 0.99 plus 0.999 and so on n times, right? First term will as it is and 7 by 9 will also as it is. Now it's time to split the terms. 0.9 can be rewrite as 1 minus 0.1, right? Similarly, second term can be rewrite as 1 minus, let's take minus common, then we will get 0.01. Third term can be rewrite as 1 minus 0.001 and so on, and same thing here we'll get n times 1 and this is also n times, right? Okay, our first term will as it is and this 7 by 9 will also as it is. Okay, now in our first bracket we have 1 n times, right? So 1 plus 1 plus 1 n times will be n, minus in the second bracket we have GP terms with A is equal to 0.1 and R, which is common ratio, 0.01 upon 0.1 will give us 0.1, which is less than 1. So actually we will need the formula list of Gn, and here it is. Our mode R is less than 1, so we are going to use the formula of Sn, which is A 1 minus R raised to n upon 1 minus R. So let's use it over here. A, which is 0.1, 1 minus R, which is 0.1 whole raised to n upon 1 minus R, which is 0.1 again, right? So everything will be as it is except this bracket. So let's write down as it is. Here we'll get 0.1 upon 1 minus 0.1 will give us 0.9, and here we'll get 1 minus 0.1 whole raised to n, right? So this is your final answer, but to get the option we just have to simplify it. Okay, let's simplify. Our first term will be as it is. Multiply this 7 by 9 will give us 7n by 9, then minus 0.1 upon 0.9 will be 1 by 9, so it will be 7 by 81, and last bracket 1 minus 0.1 whole raised to n. Okay, as you can see, none of the option has 81 over here, right? So the correct option is D. Ta-da! In our next question, we have infinity sequence in GP. 1 plus cos alpha plus cos square alpha up to dot 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 infinity is equal to 2 minus root 2. Then we have to find the value of alpha, where alpha is belongs to 0 to pi. Okay, so first of all, let's write down our series, which is in left hand side. So our Sn is 1 plus cos alpha plus cos square alpha, which is in GP, with first term is equal to 1 and common ratio is cos alpha upon 1, or we can say cos alpha. So it's time to use the formula of summation, which is A upon 1 minus R, where A is 1 and 1 minus R is cos alpha. Now here it is given that summation is 2 minus root 2, right? We just have to simplify to get the alpha. So we can say 1 minus cos alpha will be 1 upon 2 minus root 2. Let's take conjugate to get the answer. Okay, in denominator we will get 2 plus root 2, and in denominator we will get 2 square, or we can say 4 minus root 2 square, or we can say 2, and it will be 2, right? Okay, so we can say 1 minus cos alpha is nothing but 1 plus root 2 upon 2, or we can say 1 upon root 2, right? So 1 will cancel out, and finally our cos alpha will be minus 1 upon root 2, which suggests that our alpha will be 3 pi by 4, which is belongs to 0 to pi. Tada! Option D is your final answer. Now let's see one interesting question. The question is like, let S1 be the square of psi 5 centimeter. So consider this is our square having psi 5 centimeter. Now another square S2 is drawn by joining midpoint of side of S1. So this is the square which is formed by the joining the midpoint of S1. Again S3 is another square joining the midpoint of S2. So here we have S3, S4 and so on up to S10. Then we have to find area of S1 plus area of S2 plus area of S3 up to area of S10. Now first of all, let's find out the area of squares. Area of S1 can be easily found from the length of the side. Side is 5 centimeter, so we can say area of S1 will be 25 centimeter square. Now let's find out area of S2, which is actually formed by the joining the midpoint of S1. So it's actually half of area of S1, or we can say 25 by 2 centimeter square. Similarly, area of S3 will be 25 by 4 centimeter square and so on. And finally, our area of S10 will be 25 by 2 raised to 10 centimeter square. So actually here we have this sequence in GP, which is 25, 25 by 2, 25 by 2 square up to 25 by 2 raised to n. So let's collect the data of GP. Our first term is 25, then the common ratio, which is second term upon first term, is 1 upon 2, and the number of turns, total number of terms are 10. And one thing you should consider, our r is less than 1, so we are going to use the formula of Sn, a 1 minus r raised to n upon 1 minus r. So let's find out our S10. Put the value of a, which is 25, in the bracket 1 minus 1 by 2 whole raised to 10 upon 1 minus 1 by 2. Okay, 1 minus 1 by 2 will be 1 by 2, and that will give us 15 in the bracket 1 minus 1 upon 2 raised to 10. So tada! Option B is your final answer. In this question, we have three numbers in GP such that their sum is 38 and their product is 1728. And you know that whenever we have product of GP terms, we have to assume from this table, and here we have to assume three numbers. So our required terms in GP will be A by R, A and AR. Okay, now let's use the condition of terms that their product is 178. So we can say A by R into A into AR must be 1728, right? Or we can say A cube will be 1728, which give us A is equal to 12. Okay, now let's use the second condition, which is summation of the terms is 38. So here we can say A by R plus A plus AR will be 38. Now we know the value of A. Just put 12 instead of A and we will get 12 by R plus 12 R is equal to 38. We can take 2 common, and taking the LCM of R, we will get 6R square, plus 6r plus 2, sorry, 6 is equal to 19r. Okay, let's simplify this. So here we'll get 6r square minus 13r plus 6 is equal to 0. So here we get our quadratic equation, and we have to get the factors. The first factor is 2r minus 3, and the second factor is 3r minus 2 is equal to 0, which suggests that our r must be 3 by 2 or 2 by 3, right? Now let's get the terms for each option. First of all, for r is equal to 3 by 2, we already have a is equal to 12. So our terms will be 18, 12 and 8. And for 2 by 3 and a is equal to 12, we will get 8, 12 and 18, right? Both are the same thing. But here we need the greatest number, and the greatest number is 18. So option A is your final answer. Ta-da! Let's see our next question. The question is like, we have 6 positive numbers in GP such that their product is 1000. Actually, whenever we have the product of GP terms, we have to assume from this table. Now here we have to assume 6 terms. So let's assume our 6 terms are a by r raised to 5, a by r cube, a by r, ar, ar cube and ar raised to 5. Now their product is 1000. So let's multiply all the terms. A by r raised to 5 into a by r cube, a by r, ar cube and ar raised to 5. As you can see, r5, r cube and r can cancel out. So here we will get a raised to 6 is equal to 1000, or we can say our a square will be 10, which will give us a is equal to plus or minus root 10. Okay, now let's use the second condition. Its fourth term is 1. Okay, now select 1, 2, 3 and fourth term. Our fourth term is a into r, so it must be 1, which will give us r is equal to 1 upon a, or we can say 1 upon plus or minus root 10. Okay, no problem. Now we just have to find the last term, which is a r raised to 5, right? Okay, so let's find our last term, which is a r raised to 5. We already have the value of a, which is plus or minus root 10 into plus or minus 1 upon root 10 whole raised to 5. Actually here we have the odd power. That means our plus or minus will remain plus or minus, and we will get 1 upon root 10 raised to 4, right? We have 1 power and here we have 5 power, so root 10 raised to 4, which will give us 1 upon 100 as your final answer. Ta-da! Option C is your final answer. Let's see the next question. The question is, if third term of GP is 4, then the product of its first 5 terms is dash. Okay, so this product of 5 terms in GP will suggest that we have to assume from the table that our required terms of GP are a by r square, a by r, ar and ar square. Okay, now this is your first term, second term, third term, fourth and fifth term. In the question, it is given that the third term of GP is 4. That means our third term T3 is equal to 4, or we can say A is equal to 4. Okay, now what we have to find? We have to find product of first 5 terms, which are a by r square, a by r, a r and ar square. Here you can see that r square will cancel out and r will cancel out. So the product will be a raised to 5. And we already find the value of a. So 4 raised to 5. So tada! This will be your final answer. Option C is your answer. Here comes one of my favorite question. The question is like, the length of three unequal edges of rectangular solid block are in GB. The length is in GB and the volume of the block is 216 centimeter cube. And if you remember, for finding volume we have to take a product of all the lengths. So indirectly here we have three terms in GP and their product is given. So by default we have to take a help from this table, right? And here we have to assume three edges. So we are going to assume that length of the edges will be a by r, a and ar. Okay. Now we can easily find out the volume by taking the product of the terms, which are a by r into a into ar is 216, right? Here r will cancel out and we will get a cube is equal to 216, which suggests that our a must be equal to 6. Tada! Now let's go for the second condition which is given in the question. The total surface area is 252 centimeter square. So first of all, let's find out total surface area of the cube, which is equal to 2 times L into B plus B into H plus H into L, right? So let's put the values of L, B and H and we will get 2 times A by R into A plus A into AR and AR by R, right? Here you can see in third term R will cancel out and we can take A square common from the each term. So here we will have 2A square in the bracket. In first term 1 upon R, in second term R, and in third term we will have 1 as the rest of the term, which is equal to 252, right? And we know the value of A, which is 6. So let's put the value of A. A square will give us 36 and 36 7s are 252. Let's take the LCM and simplify. So here we'll get 2 plus 2r square plus 2r is equal to 7r, or we can say our quadratic equation will be 2r square minus 5r plus 2 is equal to 0. Now let's get them some space. Okay, now we have lots of space. We can easily factorize our quadratic equation and we will get r minus 2 and 2r minus 1 as your factor, which suggests that we will have two values of r. First one r is equal to 2 and second one r is equal to 1 by 2, and we already have the value of a is equal to 6, right? So the length of edges, which are a by r, a and ar, are, for first case r is equal to 2 will be 3, then 6 and finally 12, and in case of r is equal to 1 by 2 we will have 12, 6 and 3, but we need to get longest edge, and the longest edge is 12 in both cases, right? So tada! A is your final answer. In this question we have to find geometrical mean of 7, 7 square, 7 cube up to 7 raised to n. Actually we have n terms and we have to find geometrical mean of n terms, and the formula is a1 into a2 into a3 raised to an whole raised to 1 by n. So let's use this formula and quickly get the answer. Our geometrical mean will be 7 into 7 square into 7 cube up to dot 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 7 raised to n whole raised to 1 by n. Okay, let's simplify. Here we have 7 raised to 1 into 7 raised to 2, or we can say plus 2 plus 3 up to dot 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 n and whole raised to 1 by n. As you can see, in the power of 7 we have summation of first n natural number, and it is actually n into n plus 1 divided by 2, right? Now we just have to simplify. Let's write down the extra step so you can understand very well. By 2 into, we have 1 by n, and here your n will cancel out. Tada! Your final answer is 7 raised to n plus 1 by 2, option A. Here we have one question of geometrical mean. The question is like, if G is the geometrical mean of x and y, so we can use the formula of geometrical mean, and we can say our G square is equal to x into y, right? Okay, then we have to find this term. So first of all, let's write down the term. So here we have, now put the value of G square. So in first term we will get x into y minus our x square will be as it is, and in the second term same thing will happen, xy minus y square will be as it is. Now it's time to simplify. Let's take x common from the first term. So here we will get y minus x, and same thing in second term. Let's take y common, so remaining terms are x minus y. Okay, so to get equal terms like y minus x and y minus x, we can take minus common, so this bracket will be y minus x. Okay, now we can easily take the LCM. We will get minus y plus x whole upon minus xy in the bracket y minus x, right? Okay, now after taking minus common from the numerator, we will get minus y minus x. So y minus x cancel out, minus minus become plus. The final answer is 1 upon xy, but we need answer in terms of g, right? And we already know that x into y is actually your g square, so we will get 1 upon g square. Tada! Option B is your final answer.